So this is the equivalent circuit of the transformer. Transformer got the primary winding. The primary voltage is V1, primary current is I1. Primary number of turns is N1. And also got the secondary winding. Secondary winding got the secondary current is I2, secondary voltage V2, secondary number of turns is N2. So that we write down the transformer equation. V1 by V2 equal to N1 by N2 equal to I2 by I1. This means the ratio of the primary and secondary voltage equal to ratio of the primary and secondary turns, and also equal to the ratio of the secondary current to primary current. So this is the voltage and the turn ratio and the current relation of the transformer. And also we can calculate the voltage. Transformer voltage equal to 4.445 F and number of turns. Frequency plus and the number of turns multiply, then we can calculate the transformer voltage. So this is the equation to calculate the transformer voltage. Okay, based on this one, we saw the one problem. Problem 1. The primary winding of the 450/55 transformer, 400 turns. How many turns are there in the secondary winding? So there with the primary voltage V1 is 440 volt. Secondary voltage V2 is 55 volt. And transformer number of turns, primary number of turns, N1 equal to 400 turns. We need to calculate the secondary turn. So we write down the equation, transformer voltage equation, V1 by V2 equal to N1 by N2. So primary voltage divided by secondary voltage ratio equal to primary number of turns divided by secondary number of turns. So we substitute primary voltage is 440, secondary voltage 55. Primary number of turns is 400. We need to find the secondary number of turns. Then we can calculate 440 N2 equal to 55 multiplied by 400. Therefore, the N2 equal to 55 multiplied by 400 divided by 440. So from here, you can calculate the secondary number of turns is 50 turns. Secondary turn is 50 turns, we can calculate. And also that we need to calculate another problem. 240 volts is applied to the primary winding of transformer, having 1100 turns. And the secondary has 900 turns, we need to calculate the secondary voltage. So the primary voltage V1 is 240 volts. And primary number of turns N1 is 1100. Secondary number of turns N2 is 900. We need to calculate the secondary voltage. So we write down the equation V1 by V2 equal to N1 by N2. So therefore, we substitute V1 240, V2 we need to calculate, number of turns N1 1100, number of turns N2 is 900. Then we can calculate the V2. So the 240 multiply 900 equal to 1100 V2. Therefore, V2 equal to 240 multiply 900 divided by 1100. So from this way that you can calculate secondary voltage 196.3 volt. We got. The next problem. A transformer has the turn ratio 1000 to 50. We need to determine the secondary voltage. If 200 volt, 40 volt is applied to primary, this means that turn ratio A. Turn ratio A is given the 1050. This means that A is equal to N1 by N2 equal to V1 by V2 equal to I2 by I1. This is a meaning. If the turn ratio of the transformer is given, in this case we can take N1 by N2 ratio, or the V1 by V2 ratio, or the I2 by I1 ratio. This is the turn ratio A. So then we have to find out the secondary voltage. So primary voltage V1 is 240 volt. We need to find the secondary voltage V2. So we write down the equation V1 by V2 equal to turn ratio. Therefore, the V1 240, V2 we need to calculate, turn ratio is 1000 divided by 50. then we can calculate V2. So the 240 multiplied 50 equal to 1000 V2. So the V2 equal to 240 multiplied 50 divided by 1000. Therefore, the V2 will be calculated. This will be the 12 volt. Secondary voltage will get 12 volt. This will be calculated. Then we also need to calculate single phase transformer step down from 4.5 volt to 32 volt. We need to calculate the primary current if the secondary current is 2 ampere. So this is another given here. So the 240 step 32 volt transformer. So this is the V1 240, V2 32 volt. So the V1 240, V2 32 volt. Primary current 0.4 ampere. I1 equal to 0.4. We need to calculate secondary current. I2 is unknown. So we write down the equation. V1 by V2 equal to I2 by I1. So then we substitute V1 240, V2 32. I2 is unknown, I1 is 0.4. Therefore, that we can calculate I2. I2 equal to, so 240 multiply 0.4 divided by 32. So the I2 can be calculated. That will be the 3 ampere. Another problem. Single phase transformer step down from 415 volt to 32 volt. We need to calculate the primary current if the secondary current is 2 ampere. This means the step down. V1 is a 415. V2 32. I1 is unknown. I2 is 2 ampere. So we write down the equation. V1 by V2 equal to I2 by I1. Then we substitute V1 is 415. V2 32. I2 2 ampere. I1 is unknown. So that we cross multiplication. 415 I1 equal to 32 multiplied 2. So the I1 equal to 32 multiplied 2 divided by 415. So we got is 0.154 ampere. So I1 we got a 0.154 ampere. Another problem. Single phase 240/32 volt transformer, 300 primary turns, it takes the primary current 1 ampere. So we have to calculate the secondary turn as well as the secondary current. So the transformer voltage V1 equal to 240, V2 is a 32. Primary turns has the N1 equal to 300. So primary current I1 1 ampere. We need to calculate secondary turn as well as the secondary current. Voltage need to be calculated. So that we write down the equation. So that V1 by V2 equal to N1 by N2. V1 by V2 equal to N1 by N2. So the V1 240, V2 32, N1 300, N2 need to be calculated. So this is 240, N2 equal to 32 multiplied 300. So N2 equal to 32 multiplied 300 divided by 240. So then N2 is we got the 40 times. N2 40 times we got. And secondary current need to be calculated as well. V1 by V2 equal to I2 by I1. From here, we substitute V1 240, V2 32. I2 need to be calculated. I1 is a 1. So I2 is equal to 240 by 32 multiplied 1. So that will be the 7/5 ampere. The secondary current equal to 7/5 ampere we got. The next problem set. Transformer 1 with the 220 turns, primary on the primary, 40 turns in the secondary. Maximum core flow is a 0.045 Weber, supply frequency 50 Hz. We need to calculate the primary voltage, secondary voltage, and the transformation ratio. Those need to be calculated. So in this case, our transformer number of turns N1 equal to 220, N2 equal to 40. Main flux core phi equal to 0.045 Weber. Y is 0.045 Weber, supply frequency 50 Hz. So we need to calculate the primary voltage. So E1 equal to 4.44 phi F N1. So this is the equation to calculate transformer voltage. Transformer voltage, the 4/4 multiply flux multiply frequency multiply number of turns. If you want to calculate the primary voltage, in this case you need to substitute the N1. If you want to calculate the secondary voltage, you need to substitute the N2. So the E1 has to be calculated. 4.44 price is 0.045. Frequency 50, number of time is 220. Then we can calculate the primary voltage at 21984. Primary voltage 21984. Secondary voltage and can also be calculated. E2 equal to 4.44 phi F into N2. So the 4.44 flux is a 0.045, frequency 50, and number of turns. Number of turns is given there 40 turns. So then we can calculate 399.64. E2 equal to 399.64 we got. And transformation ratio is a ratio between the primary to secondary voltage. So the transformation ratio equal to, we can calculate N1 by N2. So the 220 divided by 40. So you got 5/5 is 1. 5/5 ratio 1. This is for the answer. Another problem. The transformer with a core flux of 25 milliweber, primary winding of the 1000 turns, secondary winding 1500 turns. We have to calculate the secondary voltage if the supply frequency is 50 Hz. So those is a calculate. In this case, our primary flux, core flux is the same for the both supply and the secondary. So based on the number of turns, transformer voltage will be changing. So in this case, the flux is 25 milliweber. 25 milliweber means 25 multiplied 10 power minus 3 Weber. This is the flux. Primary turn 1000. N1 equal to 1000. Secondary turns 1500. N2 equal to 1500. We need to calculate secondary voltage if the supply frequency 50 Hz. So we have to calculate E2. E2 is unknown. Frequency is 50 Hz. Okay, then we write down the equation. E2 equal to 4.44 phi F into N2. So the 4.44 phi is a 0.25 multiplied 10 power minus 3 Weber. F is a 50, N2 is 1500. Then we can calculate the E2. E2 need to be calculated. So for here we got the E2 is the 83254. This is the E2. Next problem. The maximum flux of the 50 Hz transformer is 0.001 Weber. Primary turn is the 1080 turn. Find the applied voltage. Then calculate number of turns required for 15 volts per second. So in this case, this problem, flux phi is given the 0.001 Weber. Primary number of turns N1 is 1080. We need to find the voltage V1. So the frequency 50 Hertz. So we have to calculate the primary voltage. E1 equal to 4.44 5F and 1. So 4.44 price 0.001, frequency 50 and 1 is 1080. Then we can calculate E1 is equal to the 239.8 volt. Then we also need to calculate the number of turns. Secondary voltage E2 is 15 volt. So we have to find out the N2. We write down the equation N1 by N2 equal to E1 by E2. So N2 equal to N1 E2 by E1. So the N1 is 1080, E2 15, E1 is at 239.8. From here you can calculate that way 67.6 times. So about approximately 68 times. So this is for the answer. So next problem. Single phase transformer one with the 80s are secondary turn, primary voltage 240 volt. Cofra is 2 milliweber, frequency 50 Hertz. Determine the secondary voltage, primary turn transformation ratio. So this problem here, single phase transformer one with the 80 turns. 80 secondary turn. So therefore N2 equal to 80. Primary voltage 240 volt. E1 equal to 240. Cofras 2 milliweber. Phi equal to 2 milliweber. So 2 into 10 power minus 3 Weber. Frequency 50 Hertz. F to 50. Verify the secondary voltage V2. So E2 equal to 4.44 5F and 2. So 4.44 multiply 5, 2 into 10 power minus 3. And frequency 50 and 2 is 80. Then we calculate that E2 is 35.5 volt. And also need to calculate the primary number of turns. So in this case, we can write down the equation. So you know the primary voltage, you know the secondary voltage, you know the secondary turn, you can calculate the primary turn. So we write down the equation E1 by E2 equal to N1 by N2. So this equation, E1 is 240 volts. E2 35.5. N1 is unknown, N2 is given 80. So N1 unknown, N2 is 80. So we can find the N1. 240 multiplied 80 divided by 35.5. So we can calculate. There will be the 540.5 turn, around 541 turn. Primary turn is 541 turn. Then we also calculate transformation ratio. A equal to N1 by N2 or E1 by E2. So if you use the N1 by N2, N1 is 541, N2 is 80, so you can calculate it 6.75 ratio 1. This is the way we can calculate the thing. And another problem. A 332 volt 50 Hertz single phase transformer, 600 primary turn. We need to calculate the maximum value of the core flux. So this is that we get to calculate. E1 equal to the 300 volt. E2 is a 32 volt. Primary number of turn N1 equal to 600. We have to calculate that flux. So the frequency is 50 Hz. We write down the equation. E1 equal to 4.44 5F and 1. So E1 300, 4.44. Flux need to be calculated. Frequency 50. Number of times is 600. Then flux can be calculated is 300 divided by 4.44 multiply 50 multiply 600. Therefore, the flux is 0.225 Weber or 2.25 milliweber. This is the answer. Okay, so then we can know about the transformer equivalent circuit diagram. Transformer got the primary winding, also secondary winding. So this is primary, here is secondary. When you supply the transformer to the load, so without no load, the current flow through the transformer winding. So it can happen the magnetizing as well as the transformer core losses. So that therefore that we can write down the transformer equivalent. This no load current is this is the primary winding here. Primary winding got the resistance, also inductive reactance, as well as a transformer core. This is RC and also magnetizing component HM. So this is R1 and H1 of primary resistance inductance. R2 and H2 are transformer secondary resistance and inductance. So the no load condition, the current flow to the supply go to the core loss and magnetizing. So this is for the equivalent circuit diagram for the transformer. Transformer no load current is a IN. No load current IN equal to this one is a magnetizing current and core loss current. Core loss current plus magnetizing current. That will be the transformer no load current. So this is we have to get the vector sum. Need to find the vector sum. Okay, so this problem 240/12 down step down transformer, no load current 0.6 ampere, phase angle 80° lagging. We need to draw the no load phasor diagram, magnetizing current and iron loss current. So that this no load current is normally we can draw this diagram here. This is for the core loss current, iron loss current. Here is a magnetizing current. So iron loss current is IC, magnetizing current is IM. Here we the no load current. No load current is IM. You can see this angle is an angle. So cos theta equal to power factor. So this is the way we calculate. So that this problem, no load current is 0.6 ampere, phase angle 80°. So this means the IN equal to 0.6 ampere. Angle theta is 80°. So that we can find out the magnetizing current. IM equal to IN sine theta. So the IN 0.6 sine 80. So that will be the 0.59 ampere. IC equal to coal loss iron loss IN cos theta. 0.6 cos 18. So that will be 0.104 ampere. So this is the way we calculate for the transformer no. And then also this next problem. 4 ampere a single phase 240/415 volt transformer, no load primary current 0.8 ampere. Take the 78 watt from the supply. So we have to calculate no load power factor, no load phase angle, magnetizing current, and the iron loss current. Those things has to be calculated. Therefore, the transformer here 240 and 415. So it takes the current from the supply 0.8 ampere. So this is 240 watt side. So that we can calculate power equal to EI cos theta. AC power can be calculated, voltage multiply current multiply power factor. So in this case the power is 78 watt. Voltage is 240, current 0.8, and then we can find out the power factor, cos theta. So cos theta power factor can be calculated 78 divided by 240 multiplied 0.8. Therefore, we got a 0.406 bracket. And no load phase angle beta equal to cos inverse 0.406. You got a 66 degree. Magnetizing current can be calculated. IM equal to IN sin theta. So IN is 0.8 sin 66. So you got 0.73 ampere. And also the iron loss current, IC. IN cos theta. So IN is 0.8 cos 66. Therefore, you got 0.325 ampere. So this is the way we calculate it. Next one, 254/500 volt transformer, magnetizing current 4.92 ampere, iron loss current 0.88 ampere. So that in this case 250/500 volt. So that IM 4.92 ampere, IC 0.88 ampere. We have to find no load primary current. IN need to be calculated. So IN equal to square root of IC square plus IM square. So that will be there. So 250 to 500 volt, IM 4.92, IC 0.88. IN need to be calculated. IN equal to square root of IC square plus IM square. So therefore the square root of IC 0.88 square plus IM 4.92 square. So we got that 5 ampere. And angle also need to be calculated. Angle theta equal to tangent inverse IM by IC. So tangent inverse IM is a 4.92, IC 0.88. So we got the thing is 79.8 degree. So this is IM. And another problem, 300 volt 332 volt 50 Hz single phase transformer. Primary tie is 500. We have to find the maximum value of the core flux. So the 300/32 volt 50 Hz and 1 equal to 500. We have to calculate the 5. So we calculate E1 equal to 4.44 5F and 1. So finally we calculate E1 divided by 4.44 F and 1. So E1 300, 4.44, X is 50, and Y is 500. Then you got a 0.0027 wave. So this is the answer. The next problem, transformer power you get the calculate KVA. KVA equal to volt multiplied R. This is a transformer.